So I've got 3x minus 27. If I said let's try and factor that, can anybody just raise your hand and tell me, like, how would you factor that? Or what could I do to factor that? Eli, what do you think? Pull out the 3. Okay, so what would you write as your answer? Perfect. So really all you could do there, they just have a greatest common factor between the terms. Both of those are divisible by 3. So what I'm doing there, it's like undoing a distributive property basically. So you're dividing both of the terms by 3, taking that out in front. When you have it in factored form, it should be something multiplied by something else to get the factors. So 3 is a factor, x minus 9 is a factor. Okay, now the middle one is a quadratic. So see if you remember how to factor. We're just factoring, we're not solving, we don't have an equation. All right, I got x squared minus 7x minus 44. So I got to find two numbers. When I multiply them, I get negative 44. Same two numbers. When I add them, I get negative 7. Can I think of the factors here? What do you think? Close. Are they both negative? Positive 4 and negative 11. X plus 4. It doesn't matter the order you write these in. The x plus 4 can come first or second. The x minus 11 can come first or second. Doesn't matter. If we FOILed that back out, that would give us the original problem. But what we're trying to do is write it in factored form. We multiply those two together. It gives us back the original problem. Okay, then the last one is kind of a special case of a quadratic factoring. So I have just x squared minus 36. If you want to think about what I just wrote, this would be multiply to get negative 36, and you don't have a b value here. So it would be add to get 0. Or maybe you could just think of the difference of squares property. How would I factor x squared minus 36? Like, what would the little parentheses be? Jill, what do you think? Heck yeah. One of them's x plus 6, one of them's x minus 6. When you multiply that back together, because one's a plus and one's a minus, your middle term becomes 0, and 6 times negative 6 gives you the negative 36. Second problem in a row, the order doesn't matter. You could put the x minus 6 first and the x plus 6 second and switch that up. It's the same answer. Okay. Does anybody have a question? All right, now, these two problems are just a little tiny review from yesterday. So on this graph, I really just have two connected line segments, no arrows or anything like that. Would you tell me for this number 4 right here, yes or no, would this picture represent a function? Yes, you guys are all saying, okay. Passes the vertical line test. There's no problem. If I slide any vertical line, I'm just sliding my pen. I would only ever touch one point. So this is definitely a function. Now, this is connected, right? I have segments here that are connected. So there's an infinite number of points that we're representing here. So when I write this in terms of the domain and range, which we're going to do right now, it would be an interval. We wouldn't list specific points. We only do that if you just have little dots on the graph. So we're going to have an interval here. Okay, if you're going to do domain, go from left to right. What is the first x value you touch? Negative 3. All right, should I have a bracket or a parenthesis? Bracket, because you actually, this is a filled in circle, you actually touch that point. If I keep sliding my pen, what is the last x value I touch? 2. That's your domain. I'm covering all the x values between negative 3 and 2. Nothing to the left of negative 3, nothing to the right of 2. When you do the range, just go from the bottom to the top. What is the first y value you would touch on that graph? Negative 4. So bracket again, because you got a filled in circle. And then what is the last y value you touch? Negative, what? What do we think? Negative 2? Is that what you guys are thinking? And it's kind of weird because it's on 2 different points, but that's totally okay. We don't have to have a horizontal line test. That's not a thing for functions. So it's okay that they're both on the same point. But I don't have any y value above this, so negative 2 would be the biggest y value you touch there. Okay, now yesterday we had a circle and it had the exact same domain and range because it was centered at the origin. So I have a circle here. Is the circle going to be a function? No way. This like fails the vertical line test like everywhere. So it's not a function, but that doesn't mean you can't do the domain and range. Okay, now this, obviously you can see from the picture, is not centered at the origin because the origin's like right here. So the domain and range will not be the same. Can you tell from the graph, what is the first x value that that circle touches? Somebody raise your hand, tell me. Everybody's quiet, can't say anything. -1. Ooh, I'm moving the paper, sorry. Okay, what if I keep sliding across, like I'm touching points all the way across here, I'm failing the vertical line test, but I'm touching points, so I've got x values represented. What is the last x value that you would have? 7, good deal. Okay, now this will not be the same because it's not centered at 0, 0, so the range is going to be totally different. Can you tell from the graph, what is the first y value you touch? Go ahead. Yes. And if you keep going up forever here until you get to the top of the circle, what's the last y value? Sweet. And these have parentheses because you're actually touching, like these would be points that are on the circle, like filled in circles. I know it's just kind of a solid curve around there, but you actually touch those points, so those would all be brackets. We'll have something a little bit later in the unit where we'll have a parenthesis around a number, but for now, any of the questions you're doing domain and range, if there's a number involved, not an infinity symbol, it should be a bracket. Okay, anybody have a question? Okay, now we are going to dive into function operations today, and I think what I'm going to write down here is probably the trickiest part of the whole thing because these are kind of mixed together how they are written. So I wrote one notation for each of the 4 function operation. Operations just like add, subtract, multiply, divide. That's all an operation is. The notation for this I think can be weird and it can be presented in both of the formats that I'm showing you today. So the first one's just addition. This says is how you would read it, f plus g of x. What this means, or another way you can write this, you're going to take the f of x function and add the g of x function to it. In an actual problem, you're literally just going to combine like terms. It's not terrible to do. It's just the notation throws people off, I think. Now, this one right next to it says f minus g of x. What this means is you're going to take the f of x function and you're going to subtract the g of x function from that. That one can be kind of tricky because you have, if the the function you're subtracting has more than one term, you have to distribute that subtraction symbol, so we'll get into that in a second. And then the other two, we got multiplication and division. So this says f times g of x. Another way you can write it, this would be the f of x function times the g of x function. So it could be maybe just a little distributive property. It could be like a FOIL. It just kind of depends on the question. And then the last one, this is f divided by g of x. This is the same thing as the f of x function divided by the g of x function. Now, this one can get tricky. This is why I wanted to review the factoring. We're going to factor the top and bottom of any question that's division if we can, and see if anything cancels out, and that'll make more sense in a second. So, adding and subtracting, we're just going to be combining like terms. It's not bad to do. So if you guys want to look down here, I've got two, that's shaking all over the place, sorry. I've got 2 functions in the directions, so make sure you read the directions because they'll probably change up what function you are working with. So the first one, the f of x, is just a quadratic, and the second one, this is just linear, just 8x minus 6. Okay, we're going to take f of x plus g of x. So literally, all we're going to do, your f of x, maybe I'll use the same color that the function is, that would make sense. We're going to have 5x squared minus 4x plus 3, and to that, I'm just going to add 8x minus 6. So I'm literally just basically substituting what f of x is equal to in for f of x, what g of x is equal for g of x, and then all you have to do to answer the question, just combine any like terms if you can. So that's all we're doing, just simplify this. So I only have one term with an x squared, right? Just 5x squared. All right, for my x's, I've got negative 4x and I've got 8x. So if I put those guys together, that should be 4x. And my plain numbers, my constants, I've got 3 and negative 6. So if we put those guys together, it should be negative 3. That is the answer if you add those 2 lovely functions together. It's not bad. Does anybody have a question? Okay, so these notations are kind of mixed. Remember, this is the same thing. This is f minus g of x. This is the f of x minus the g of x, if you like that notation better. So f of x, I'm just going to copy that down again here real quick. That 5x squared minus 4x plus 3. Now, if you're working with a subtraction problem, be really, really careful with this. So I have to subtract the entire g of x function. And in this problem, based on the directions, the g of x function has two pieces to it, or two terms. I would just recommend anytime you're working with a subtraction problem, whatever you are subtracting, just put it in parentheses real quick and make sure you distribute the subtraction to each of the terms of the function that you're subtracting. Because a lot of times people get the first term okay, but they'll mess up the second one. So really, this should be 5x squared minus 4x plus 3. If I distribute that subtraction, it would be minus 8x, and then minus a negative 6 actually would turn into plus 6. So if I distribute that subtraction to that entire function there, that's going to change both of the signs. And then just combine like terms like we did on the last one. So let's see. Only one term with the x squared, 5x squared. You got negative 4x, negative 8x, so negative 12x. And then 3 and 6 are going to add up to 9. Does anybody have any questions? Okay, now notice like when we did these two problems, they had an x in the problem, and our answer had an x in it, like an expression. So if you have f of x, g of x, your answer, unless it's something super weird, should have an x in it. The next two questions have numbers in them. If you have a number here for any of these operations, your answer should be a number. It might not be a nice number, but it should be a number. So same functions here. What this means, we're going to take f of negative 2 plus g of negative 2. So this is really similar to what we were doing in our last lesson, where you're just going to plug in those values and figure out what they are. All right, and of course I've got my functions off the screen, so I'm going to pull this and move this. I'm just going to grab my calculator. You might want your calculator for a couple of these problems. I'm going to plug negative 2 into that f of x function. And don't forget, especially if you're working with a negative, if you're going to square it, feel free to type it in your calculator, save yourself some time, but make sure if you're squaring a negative number, which I'm going to do if I plug in negative 2, put that negative number in parentheses and put the squared on the outside, because that should always become positive there. And then I've got minus 4x. Everywhere I see an x, I'm just going to replace it with negative 2, and then plus 3. So I'm literally just finding the f of negative 2 here, so that's 31. And then g of the same number, so make sure you switch to the other function. So the g function is 8 times our x value minus 6. Our x value here is negative 2, so I know you can do this by hand. I'm just being lazy and doing it on my calculator. But I do 8 times negative 2 minus 6, and I got negative 22. So this would be plus negative 22. You don't have to write that step if you don't want to, but this ends up being plus a negative is really just subtraction. So it's 31 minus 22, and that's going to give us our final answer, which is just 9. So if you have variables in your question, your answer should be an expression of some kind with a variable, but if you have a number, then your answer should be some kind of number. All right, so let me write down what this one means, and then you guys try this one. So this would be, g comes first here, so it would be g of 3 minus f of 3. So see if you can figure out what that should be. If I did g of 3 and then minus f of 3. So you're just going to plug 3 everywhere you see an x into the f of x and the g of x. Did you make it? Just tell me what g of 3 was. What was the number there? What was it? 18? Okay. What was the f of 3? Did you get 36? All right. So my answer, all we have to do there, subtract 18 minus 36, actually negative 18. Anybody having a question? Okay. All right, now we'll do the little bit trickier ones on the back. Okay, so the little bit trickier ones are going to be multiplication and division. The same thing as the front, though. If you have a number as part of your question, then your answer should be a number. If you have variables inside the parentheses, then your answer is probably going to be an expression of some kind. All right, so this says h times g of negative 5. So this one means h of negative 5 times g of negative 5. So we're going to multiply together here. Now, they did switch up the different functions here. So this time f of x is linear. It's 2x plus 8. G of x is a quadratic. I've got x squared plus 5x plus 4. And h of x is linear. It's just going to be x plus 1. So just make sure you're reading the directions and you don't get tripped up and kind of use functions from a different set of directions on accident. All right, otherwise it's the same thing we did on the front. So like if I do h of negative 5, where's the h? Don't judge me for typing this on my calculator right now. Okay, so h of negative 5 would just be negative 5 plus 1. So this is negative 4. G of negative 5. Okay, when you do this, very important, especially if you're plugging a negative number into a quadratic. So this is supposed to be x squared. So everywhere I see an x, I'm going to replace it with negative 5. Make sure you just put parentheses around that and put the squared on the outside. If you don't do that, the calculator will tell you negative 25, which is not correct. So just be careful with that. Then it'd be 5 times negative 5 and then plus 4. So this ends up being positive 4. And then all we got to do to answer the question is literally multiply those together. So negative 16 would be my final answer. It's not bad to do. Just make sure you're plugging it in the right function. The one next to this, f divided by g of 4. So I'm going to do f of 4, and I'm going to divide that by g of 4. So the f of x function's the first one that's listed there. We're just doing 2x plus 8. So 2 times 4 plus 8. So the top of that fraction would be 16. And then g of 4, that's a little bit more work because it's a quadratic. So I'm going to do 4 squared, 5 times 4, and plus 4. This is 40. And it's really early and I'm feeling really lazy. Don't judge. So I'm going to do 16 divided by 40. Math, enter to convert that because I'm being lazy. And that's 2/5 if you reduce that. Is anybody having a question? Okay, if you got numbers, you're going to plug in numbers. Your answers are going to be numbers, like those two questions. Now, the next two questions, these are multiplication, and you have variables. All right, so it's f of x times h of x. So f of x is the 2x plus 8, and h of x is x plus 1. So this is literally just a FOIL. Just FOIL. All you're going to do, or if you like to draw the box, you can draw a box as well. So I'm just going to FOIL real quick. It's a double distributive property is what it is. 2x times x is going to give you 2x squared. 2x times 1 would be plus 2x. And then I'm going to multiply both these guys by 8. So I'm going to get 8 times x is 8x, and 8 times 1 is 8. And not always, but a lot of the time you can combine some like terms, which we can here. 2x and 8x are going to give us 10x in the middle there, plus 8. That's in standard form. Now, I know it's probably really tempting. You're probably like, oh, all those terms are divisible by 2 to like pull. Don't factor that. You're actually multiplying it out to simplify it. So I know you could pull a 2 out and things like that, but just leave that alone. That's going to be your answer. All right, if I do f of x, again, this is this 2x plus 8 times g of x. That was the quadratic. The x squared plus 5x plus 4. This is like FOIL on steroids. It's like a triple distributive property. So if you do like to draw a box, just draw like a 2 by 3 box. If you like to do the FOIL, I'll just go through, if you had Mr. Shramick, I do this a little different maybe. But I just take the 2x times all three of those terms. So I'm going to have 2x cubed plus 10x squared and then plus 8x. And then what I do, just to help me make it a little easier to combine like terms, is when I do the plain number, the 8, I try to stack up like terms underneath each other. So like if I do 8 times x squared, I get 8x squared. I just write that underneath the other x squared term. If I do 8 times 5x, I get 40x. So I'm just writing that underneath that other term. And then 8 times 4, 32. And then I just kind of add these vertically, basically. So there's only one term with x cubed. X squared, you got 10 and 8, so we got 18 of those. For x's, we got 8 and 40, so we got 48 of those. And then there's no other plain number, just the 32. And again, I know all these terms are divisible by 2, but you don't want to factor anything. We're trying to multiply these out and put them in standard form. So that's going to be my answer. Does anybody have a question? Okay, now, these last two are the trickiest. So, when you're working with division, right, I'm literally just going to copy the functions here. This says f of x divided by g of x. If we're working with numbers, this is not as big of a deal, but if you're working with variables, this can confuse people. Okay, let's see. F of x is 2x plus 8, and g of x is x squared plus 5x plus 4. Okay, you can't just go, oh, I see an x here and an x here and cross them out, or I see an 8 here and a 4 here and that's 2. It doesn't work like that. You have to divide 2x by this entire quadratic, and you have to divide 8 by this entire quadratic. So you can't just cancel things out, and that's the biggest thing people get tripped up on here. The only way you can cancel things out is if you have things that are multiplied together. If you have adding or subtracting, you cannot do that. So what you want to do on any of these questions is just see if you can factor either the numerator or denominator or both in any way. So on the top of this fraction, can you factor 2x plus 8 in any way, just like factored form, kind of like we did at the very beginning of class today? Like, do 2x and 8 have anything in common? 2. Okay, so on the top, I'm just going to, greatest common factor here, this would be 2 times x plus 4, right? That's the factored form. So now what I have is two things multiplied together, right? 2 times x plus 4. Okay, could you factor the bottom? So that's just a 3 quadratic trinomial there. So I'd have to multiply to get 4 and add to get 5. Can anybody think of factors? Eli, what do you think? 1 and 4. So x plus 1, x plus 4. Okay, now, after you factor, on the top, I have two things multiplied together. On the bottom, I have two things multiplied together. We don't have just plain addition in this question. Here's how this works. If two of the factors match, which they do, then you can cancel them out. So x plus 4 on the top, x plus 4 on the bottom, those do cancel each other out. And so my answer here would be 2 over x plus 1. So you got to put it in factored form before you cancel anything. It doesn't work the other way. So just whenever you get to a division question, if you're working with a variable, we're going to see if we can factor it. And then if anything matches on the top and bottom, then you can cross it out. Okay, so similar question, but two different functions. So g of x was what? The quadratic. So the x squared plus 5x plus 4. H of x was x plus 1. Okay, I can't really factor anything on the bottom. It's just x plus 1. But on the top, we factored that in the last question, so I'm just going to copy that. We had x plus 1 times x plus 4 was the factored form. Okay, now, because the top is in factored form, it's two things multiplied together. That x plus 1 and that x plus 1 on the bottom, they match. So you can cross this out. And the answer, the fraction would actually totally get eliminated there, and the answer would just end up being x plus 4. That doesn't happen every time, but if you're going to cancel anything out with a division question that involves variables, you have to make sure you factor first. Is anybody having a question?